Hello, and thank you for clicking on How to Check Your Sequences and Series exam question booklet. The first part of this booklet is using the recurrence relationship part of the chapter. To solve questions like this, you need to understand that if un equals 1, u2 will be u1 minus 3 squared, u3 will be u2 minus 3 squared, and u4 will be u3 minus 3 squared. So we're going to stick in un equals 1 first of all. So u2 equals 1 minus 3 squared, which is minus 2 squared, which is 4. u3 is u2 minus 3 squared, which is 1 squared, which is 1. And u4 is u3 squared minus 3 squared, which is minus 2 squared, which is 4. So from here you might have noticed that the odd terms are all 1 and that the even terms are all 4. So part B, it asks for u20. Clearly you don't need to go all the way up to u20. u20 is an even term, so it must be 4. Okay, question 2 again. If we want to find u2, it's going to be 3 lots of u1, take away 5. If we want to find u3, it's going to be 3 lots of u2, take away 5. So we have part A, u2, the second term, 3 lots of u1, which is 3, take away 5, so 9 take 5, which is 4, and then the third term, u3, we have 3 lots of 4, take away 5, 12 take 5, which is 7. Part B, we want to sum the first 5 terms. Now we could use our SN formula, but as we've already got the first term, the second term and the third term, it's probably much easier just to find the fourth term and the fifth term and add them together. So the fourth term is 3 times 7 take away 5, which is 21 take 5, which is 16. And u5 is 3 times 16 take away 5, which is 48 take 5, which is 43. So we just need to add together 3, add 4, add 7, add 16, add 43, the first 5 terms, and here we get 73. Okay, another recurrence relationship. So if we want to find A2, we have 3A1, add 5. If we want to find A3, it would be 3A2, add 5. So we need to write down an expression for A2 in terms of K. So A2 is 3 times A1, which is K, add 5. For part B, we need to show that A3 equals this. So we're going to do A3 is 3 lots of A2 plus 5, and we multiply that out to get 9k add 15 add 5, which is 9k add 20. So we've done that, part B. Part C, it says find the sum of the first 4 terms in terms of k. Again, we've got A1, A2, A3, it's just as easy to find A4. A4 is 3 lots of A3, add 5, which is 27k, add 60, add 5, which is 27k, add 65. And then the second part, also find the sum of the first 4 parts, so we're going to add all of these expressions together. So A1 was k, A2 is 3k, add 5, A3 was 9k, add 20, and A4 was 27k, add 65. When we add these together, we should get 40k, add 90. Part 2 says show that the sum of the first 4 terms is divisible by 10. Whatever you're asked to prove it's divisible by, this number will definitely be a factor of the expression that you found. So for part 2, if you're just able to say that 10 is a factor, then you have proved 10 is a factor. You've also proved there that it's divisible by 10. It's worth having the supported statement rather than just writing out 10 outside of the bracket. You've got 2 marks for each of these, so I would definitely write the supportive statement. Okay, another recurrence relationship question, number 4. Just to keep going with this, so x2 will be found by using x1 bracket p add x1, and the x3 will be x2 bracket p add x2. This line here, where p is a constant, p is not equal to 0, will become very important later on in the question. So it is important, I'm going to underline it now. Find x2 in terms of p. So we have x2 equals 1 bracket p add 1, which is just p add 1. Show that p3 equals this expression here. So we have x3 equals x2, which is p add 1, bracket p add x2. So we're going to simplify that and expand the bracket. So that equals p add 1 bracket 2p add 1 close bracket. So when we multiply that out, we get 2p squared add 3p add 1. So we've proved it. It says here that x3 is equal to 1. Find the value of p. So we have that 2p squared add 3p add 1 equals 1. When we factorise a quadratic, it's got to equal 0. So we've got 2p squared add 3p plus 1 minus 1 equals 0. So 2p squared add 3p equals 0. Single bracket needed here. P bracket 2p add 3 equals 0. So either p equals 0 or p equals minus 3 over 2. Notice back at the beginning of the question it said p is a constant and p cannot be equal to 0. So p is minus 3 over 2. Now that we have p, it says write down a value of x 2008. Okie dokie. We don't really want to do 2008 terms. Let's see if there's a pattern. So x1 was equal to 1. x2 was equal to p add 1, so that's minus 3 over 2 add 1, so minus 1.5 add 1 is minus 1/2. x3 was equal to 2p squared add 3p add 1, so 2 times minus 1/2 squared add 3 times minus 1/2, minus 1.5, add 1. We expand this and we get that x3 is actually 1. Now, without me doing anything further, I'm going to make this prediction. You could do an x4 just to prove it, but it looks like the odd terms are going to be 1 and the even terms are going to be minus 1/2. So for part D, x to the 2008, which is an even term, the answer will be minus 1/2. Okay, on to question 5. To find x2, we will be doing ax1 minus 3, and to find x3, we'll be doing ax2 minus 3. So part A says find an expression for x2. x2 is a times x1. x1 is just 1, so it's a minus 3. Part B, show that x3 is this. So x3 is a times x2. Take away 3, multiply it out. We've got a squared minus 3a minus 3. We've proved it. It then says, given that x3 equals 7, find possible values of a. Now it hasn't said anything, it just says a is a constant. It hasn't said that it can't be 0, just says that a is a constant. So we've got a squared minus 3a minus 3 equals 7. A squared minus 3a minus 10 equals 0. So when we factorise, it's got to equal 0. This factorises quite nicely into 2 brackets, a minus 5, a add 2, because we needed numbers that multiplied together to give you minus 10 and added together to give you minus 3. So a could be 5 or a could be minus 2. There we have it, end of the question. Okay, the last question in this recurrence relationship section. To find a2, we'll do 2 times a1 take away 7. To find a3, we'll do 2 times a2 take away 7. So if we want to find a2, we're going to do 2 times k take 7, 2k minus 7. To find a3, we're going to do 2 lots of a2, which is 2k minus 7, take away 7, expand that to get 4k minus 14, take away 7, for 4k minus 21. To find the sum of the first, we're told that the sum of the first 4 terms is 43. We need to find a value of k. We really need to find the a4. So a4 will be 2 lots of 4k minus 21, which is 8k minus 42. So we're going to sum those first 4 terms together. So we get k add 2k minus 7, add 4k minus 21, add 8k minus 42. This gives us 15k minus 77. That equals 43. This means that 15k equals 120. So k equals 8.